Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is logarithmic differentiation in problem solving. In our previous video, we discussed what is logarithmic differentiation. Now we are going to see many examples in different difficulty levels. So let us start with the example one by one. These are the basic formulas that we are going to apply in logarithmic differentiation. Here is the first example. Please look at the question. We are supposed to differentiate this expression y equal to x raised to e raised to x. Please look at the question here. Because a variable is raised to a variable power in this function, the ordinary rules of differentiation do not apply at all. The function must be revised before a derivative can be taken. So let us begin with this. Y equal to x raised to e raised to x. So we are going to apply the natural logarithm to both the sides of the equations. So we will get, so once you take the natural logarithm, the term or any expression in the exponent's place will be shifted to the coefficient's place. That is the nature of this rule. That is the reason why we are taking natural log on both the sides of the equation. So whenever if you want to bring something from the exponent's place to the base place, you can apply this law. Now we are going to differentiate both the sides of the equation. The left hand side requires the chain rule, since y represents the function of x now. Use the product rule on the right hand side. Thus, beginning with this, ln of y equal to e raised to x ln of x, and differentiating, we will get, since I am applying chain rule here, differentiation of ln of y is nothing but 1 over y, and again differentiating the function within this will be y dash, because dy by dx is nothing but y dash. Now we are going to apply product rule on the right side, because we have two functions, e raised to x times ln of x. We are going to apply product rule. So first function and second function. So that would become, keep the first function as it is and find the derivative of second function. Second function is 1 over x, plus you have to find the derivative of e raised to x is nothing but e raised to x itself, and keep the second function as it is. Hope you're clear with the product rule on the right hand side. Under the topic logarithmic differentiation, we are not only going to apply the logarithmic rules alone. We are going to do a combination of the rules. We are going to use whatever rule is applicable at each and every step. Now get a common denominator and combine the fractions on the right hand side. So that I'll be getting, if I am multiplying both numerator and denominator by x, both fractions will become the fractions with same denominator. Are you clear with this step? I have just multiplied the fraction. 1 over y multiplied by y dash is equal to y dash over y, and e raised to x times 1 is e raised to x. I am keeping the denominator x as such, and for this one I am multiplying the numerator and denominator by x, so I get x times e raised to x ln of x in the numerator and x in the denominator. Please notice that the denominators are same, so I am going to take that as a common and write the numerators with plus sign in between. Multiply both the sides of the equation by y. So we will get, now we are going to back substitute the value for y. So y is equal to the given question. I'm going to replace y by x raised to e raised to x. Now combine the powers of x. So I'll get x raised to e raised to x minus 1. That's it for this example. So you have to finally shift everything to the right side of the equation and keep y dash isolated on one side of the equation. This is how we do the logarithmic differentiation for this example. Hope you're clear with this example? Okay, let me show another example. In our previous video, I took the very basic example. Now we discussed a problem with the exponential function. Now I have taken a polynomial here. Now we are going to apply logarithmic differentiation here. Please look at the question and understand that a variable is raised to a variable power again in this function. So the ordinary rules of the differentiation do not apply here. So the function must be revised before a derivative can be taken. So let's begin with this question. Applying natural logarithm on both the sides of the equation. Why we are taking natural logarithm? Because we are going to bring this exponent variable to the base place. That is the reason we are applying natural log on both the sides of the equation. So let's see what will happen if I take the natural log. On the right side of the equation, the exponent will be shifted to the coefficient's place. So this will become This can again be written as multiply the terms in the numerator's place. 1 times ln of 3x square plus 5. Now let's differentiate both the sides of the equation. The left hand side requires the chain rule. Since y represents a function of x, and we are going to use the quotient rule and chain rule on the right hand side because we have two functions in the numerator and denominator. So we are going to apply quotient rule. Again, please notice that there is another function within the parenthesis of the ln function. So we are going to apply chain rule also on the right hand side. Thus, we will get, by differentiating, we will get 1 over y and y dash on the left side because we are applying chain rule. Now on the right side, we are going to apply quotient rule. There is one function in the numerator and another function in the denominator. So keep the second function as it is and find the derivative of first function. Derivative of ln of 3x square plus 5 is nothing but 1 over 3x square plus 5. Again, there is a function within the ln function. So if you are finding the derivative of this inner function, we are applying chain rule here. So 3x square is nothing but 3 times 2x. So 3 times 2 is 6. So we are getting 6x by applying the chain rule. Now let's get back to the quotient rule. We did the first part. Now write the negative sign in between. Keep the first function as it is. ln of 3x square plus 5 and find the derivative of second function. Second function derivative is nothing but 1 divided by second function the whole square. This is how we apply the quotient rule. There are two functions. Keep the second function as it is, find the derivative of first function. Since there is another function within the function, we are applying chain rule here. And negative sign in between, keep the first function as it is, find the derivative of second function, divided by second function the whole square. This is called quotient rule. Now, get a common denominator and combine the fractions in the numerator. So, this term has a denominator 3x square plus 5. If you want the denominator to be same, you have to multiply and divide the second numerator by 3x square plus 5 by 3x square plus 5. Now dividing by a fraction is the same as multiplying by its reciprocal. Am I right? We are just doing fractional division here. Keep the numerator as it is and change the division sign into multiplication and take the reciprocal of the second fraction. Hope you are clear so far? Now multiply the terms in top row and multiply the terms in bottom row. So 1 times anything is the term itself. And in the denominator we will get x square times 3x square plus 5. Now let's multiply both the sides of the equation by y, so that we can get rid of the y in the left side of the equation. Now plug in back the value given in the question for y here. Only if you substitute back, the answer will be complete, or else it will be considered as an incomplete answer. Now it remains to combine the powers of 3x square plus 5. So if I combine, it will become, that's it for this example. So finally you have to substitute back the y value and then give the isolated value for y dash on the left side of the equation. That's it for this example. Hope you're clear with this example. It may look somewhat difficult, but when you move step by step, it will be very easy. You should be careful while applying the quotient rule, chain rule, because it is all a combination. So when you're applying a combination of rules, you have to be a bit more careful. Once you practice some problems, it will be easier for you to identify which rule to apply at which step. So far we discussed a polynomial function. Now I'm going to take a trigonometric function sin x. Here is the next example. Differentiate y equal to sin x raised to 3. Now as usual, here a variable is raised to a variable power in this function. Therefore, the ordinary differentiation rules does not apply here. The function must be revised before a derivative can be taken. So let's begin with this question. Applying the natural log on both the sides of the equation, we will get, as I already told you, the reason why I am applying natural log on both the sides is to bring the variable from the exponent's place to the coefficient's place. Now, the right side of the equation would become, I have just shifted x cubed to the coefficient's place. Now we are going to differentiate both the sides of the equation. The left side of the equation requires the chain rule since y represents a function of x. And on the right side, please look at the question, x cubed times ln of sin x. The functions are being multiplied. So we are going to use product rule. As usual, there is a function sin x within another function. So we will be also using chain rule on the right hand side of the equation. Thus, let's begin with ln of y equal to x cubed times ln of sin x, and differentiating we will get. So I'm applying chain rule and product rule here. Actually the product rule is applied and there is a function within the ln, so I'm applying chain rule here. Keep the first function as it is and find the derivative of second function, 1 over sin x. Again chain rule, derivative of sin x is cos x and plus sign in between. Keep the second function as it is and find the derivative of first function. Here we are applying power rule. X cube is nothing but 3 times x raised to 3 minus 1, which is equal to 3x square. Does this make sense to you? So now we need to get a common denominator and combine the fractions on the right hand side. So on the right term, we have two terms. Already there is a denominator for the first term, but for the second term there is no denominator. We need a denominator sin x. So I'm just going to multiply the numerator and denominator by sin x. The general concept that we do in fractional addition. We add or subtract two fractions only when the denominators are same. That is why I'm making the denominators same here. I'm multiplying and dividing the second term by sin x over sin x. So after multiplying, taking the common denominator, I get. Hope you're clear till this step. Now we are going to multiply both the sides of the equation by y, because we wanted to get rid of this y from the left side of the equation and isolate y dash alone, because the question is asking us to do the logarithmic differentiation. So it means y dash should be isolated on one side of the equation and all the other terms should be shifted on the other side of the equation. So after multiplying both the sides of the equation by y, I'm getting just cross multiplication. Now we need to back substitute the value given in this question. We started with some expression initially. So I'm going to plug in back that value for the y here. Y can be replaced by sin x times sin x raised to x cube. And finally we are going to combine the powers of sin x to make it a neat simplified one. That's it for this problem. Hope you're clear with this example. These questions look very complicated initially, but when you analyze the question, you can understand what are all the rules can be applied. So whenever you get a variable in the exponent's place, it is better to start with taking natural log on both the sides of the equation. And according to the nature of the expression, you can apply product rule or quotient rule. Even if there is a function within another function, you can apply the chain rule and simplify your answer as much as possible. Also please make sure that in case if you have any other term on the left side except y dash, you have to shift that to the right side of the equation by doing the opposite operations. Generally we do in the algebra. Hope you're clear with these examples. Okay, I guess you got some idea on logarithmic differentiation now. In case if you get any query,